Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll walk you through the fundamentals of AWS SAM, the Serverless Application Model, and how it simplifies the development, testing, and deployment of serverless applications on AWS. We'll cover everything you need to get started, from understanding SAM templates and CLI commands to building and deploying a fully functional application using best practices. Let's get started. AWS SAM is an open-source framework designed to simplify the development and deployment of serverless applications on AWS. It allows you to define your infrastructure as code using a clean and compact YAML syntax. With just a few lines, you can declare your Lambda functions, API gateway endpoints, DynamoDB tables, SQS queues, and more, all in one unified template. Under the hood, SAM is built on top of AWS CloudFormation, so everything you define gets transformed into native CloudFormation resources. This means you get all the benefits of CloudFormation's stability and maturity, while enjoying the syntactic sugar that SAM provides to streamline your workflow. One of the standout features of SAM is its powerful command line interface, the SAM CLI. It enables local development and testing by simulating the Lambda runtime using Docker containers. This means you can build, test, and debug your serverless code entirely on your local machine before deploying to the cloud. SAM integrates seamlessly with CI/CD pipelines, making it ideal for DevOps teams looking to automate serverless deployments. Whether you're using AWS Code Pipeline, GitHub Actions, or Jenkins, SAM fits right into your toolchain. It also encourages best practices by supporting versioning, aliasing, and staged deployments. And when it comes to security, SAM can automatically generate IAM roles and fine-grained permissions, while still giving you full control when needed. Finally, SAM is open source and extensible, backed by AWS and a vibrant community of contributors. Whether you're just starting out with serverless or looking to improve how you build and manage cloud-native apps, SAM is a powerful tool that bridges simplicity and scalability. Let's look at some of the key benefits that make it such a valuable tool for building serverless applications. First and foremost, SAM makes infrastructure as code significantly easier. With its simplified and declarative YAML syntax, you can define entire serverless architectures, including Lambda functions, API gateway routes, databases, and event sources, in just a few lines. This reduces boilerplate and improves template clarity, making it easier to collaborate and maintain your infrastructure. The SAM CLI is another major advantage. It allows you to build, test, and debug your Lambda functions locally using Docker containers that replicate the AWS runtime. This accelerates development and gives you confidence in your code before pushing it to the cloud. Deployments are streamlined through SAM Build and SAM Deploy, which automate the process of packaging, uploading, and launching your serverless app. There's no need for custom deployment scripts or manual steps. It just works. SAM also enforces best practices by default. It supports Lambda versioning, aliasing, and traffic shifting, enabling you to deploy changes safely and roll back if needed, all integrated with services like AWS Code Deploy. For teams practicing continuous integration and delivery, SAM fits seamlessly into CI/CD pipelines. Whether you're using Code Pipeline, GitHub Actions, or any other tool, SAM commands integrate cleanly into your workflow. Security is also simplified. SAM automatically generates IAM roles and permissions for your resources, helping you enforce the principle of least privilege with minimal configuration. Finally, because it's built on CloudFormation, SAM gives you access to advanced stack management capabilities and customization when needed. At the heart of every SAM application is the SAM template, typically named template.yaml. This declarative YAML file allows you to define all your application resources in one place, including compute, APIs, databases, event sources, and more, using simplified syntax built on top of AWS CloudFormation. One of the most important resource types in SAM is function resource. This defines your Lambda functions and includes all the essential properties such as the runtime environment, the handler, memory and timeout settings, environment variables, and the event sources that will trigger the function. To expose your functions over HTTP, you can use API resource. This component defines an Amazon API Gateway's REST API and allows you to map HTTP methods and routes to specific Lambda functions. You can even integrate an open API specification and configure stages and throttling settings directly in the SAM template. If your use case is more lightweight, or if you're building simple HTTP-based services, SAM provides HTTP API resource. This uses API Gateway v2 and is optimized for performance and simplicity, especially when you don't need the full feature set of a traditional REST API. For data persistence, SAM includes the simple table resource. It provides a quick and easy way to spin up a DynamoDB table with sensible defaults, making it ideal for development or proof of concept applications. SAM also shines in supporting event-driven architectures through its event sources. With native support for S3, SNS, SQS, API Gateway, DynamoDB streams, and more, you can easily connect your Lambda functions to a variety of AWS services and trigger them based on real-time events. Finally, the global section of your SAM template allows you to define shared configuration across multiple resources. For example, setting a common timeout or memory size for all functions. This not only reduces redundancy, but also promotes consistency across your application. To truly understand how AWS SAM works, it's important to look at the anatomy of a SAM template. This template is a YAML file that serves as the blueprint for your entire serverless application. Let's break down its key sections. First comes the transform section, and this one is critical. It tells CloudFormation to process the template using the SAM macro. You'll always set this to AWS serverless-2016-10-31. This enables all the SAM-specific resource types and syntactic shortcuts that make working with serverless infrastructure easier. The globals section allows you to define default properties that apply to all relevant resources, like functions or APIs. For example, you can set a global timeout or memory size for all Lambda functions, reducing redundancy and enforcing consistency across your template. At the heart of the template is the resources section. This is where you define all your application components, including Lambda functions, APIs, event sources, DynamoDB tables, and more. Each resource uses a specific type and includes configuration details like runtime, handler, and triggers. The parameters section is another important part. It allows you to pass in environment-specific values at deployment time, such as table names, stage names, or ARNs, making your template reusable across dev, staging, and production environments. Finally, there's the output section. This is where you define values that should be returned after deployment, things like function ARNs, API endpoints, or S3 bucket names. These outputs are especially helpful for visibility, CI/CD pipelines, or chaining stacks together in a larger system. AWS SAM is designed with automation in mind. The SAM CLI provides key commands like SAM build, SAM package, and SAM deploy, which can be scripted into any CI/CD pipeline. These commands handle everything from compiling your code and creating CloudFormation-compatible templates to uploading artifacts and deploying the stack. SAM makes it easy to support multiple environments like development, staging, and production. Using parameter overrides and configuration files, you can deploy the same application template to different environments with environment-specific settings. One of the major strengths of SAM is its compatibility with popular CI/CD platforms. Whether you're using GitHub Actions, AWS Code Pipeline, GitLab CI/CD, Jenkins, or Bitbucket, SAM integrates seamlessly. This allows teams to automatically build, test, and deploy their serverless apps as part of every code change or pull request. You can also embed automated validation and testing steps directly in your pipeline. SAM commands let you run unit and integration tests against local emulations of your Lambda functions and APIs. Security is built in too. Pipelines can use IAM roles or OIDC to securely access AWS resources without exposing credentials, a must for secure and scalable automation. For more controlled deployments, SAM supports CloudFormation change sets, allowing you to preview and approve infrastructure changes before they're applied. And when integrated with AWS Code Deploy, SAM enables advanced deployment strategies like canary or linear rollouts with automatic rollback if errors are detected. Lastly, SAM's build process outputs useful artifacts, package templates, deployment bundles, and logs, which can be archived or promoted across environments as part of your release management strategy. In traditional serverless development, one of the biggest challenges has always been the slow feedback loop when code changes are made. That's where SAM Accelerate comes in. It's a set of powerful capabilities built into the AWS SAM CLI that dramatically shortens the development cycle and lets you push changes to the cloud faster than ever. At the heart of SAM Accelerate is the SAM sync command. Unlike a full deploy, SAM sync intelligently detects what's changed, whether it's your Lambda function code, templates, or configurations, and updates only those specific parts in the cloud. This enables near-instant hot swapping of function code and incremental updates to infrastructure, making the development loop much more agile. One of the key advantages of SAM Accelerate is that it lets you test changes directly in the cloud. That means you're no longer relying solely on local emulators or mocks. You're testing against real AWS resources, APIs, DynamoDB tables, event triggers, which results in more accurate debugging and fewer surprises when deploying to production. SAM Accelerate also supports all major Lambda runtimes, including Python, Node.js, Java, Go, and .NET, so it fits seamlessly into your team's existing tech stack. And because it integrates naturally with the rest of the SAM CLI, including commands like SAM build, SAM local, and SAM deploy, there's no need to rework your toolchain or CI/CD workflows. It simply plugs in and enhances what you already have. Ultimately, SAM Accelerate is about empowering developers, leading to faster feature delivery and higher code quality. When building serverless applications in the cloud, security and compliance are not optional, they're foundational. To start, SAM gives you fine-grained control over IAM roles. You can assign a unique role to each Lambda function, ensuring each one has only the permissions it truly needs. This follows the principle of least privilege and helps isolate risks between services. For managing secrets like API keys or database credentials, SAM integrates seamlessly with AWS Secrets Manager and SSM. These services let you store and retrieve secrets securely, with automatic encryption and access control. Because SAM uses infrastructure as code, all security configurations are defined declaratively in YAML templates. This not only improves repeatability and transparency, but also allows your infrastructure changes to be tracked in version control. You can also integrate automated security scanning tools into your CI/CD pipelines. Services like Amazon Inspector or third-party tools can check for vulnerabilities in your code, dependencies, and infrastructure settings. SAM supports secure deployment practices such as running Lambda functions within VPCs, applying security groups, and encrypting environment variables. Data at rest and in transit can be encrypted using KMS, helping you meet industry regulations and internal security policies. With AWS CloudTrail and CloudWatch, you gain full visibility into how your application is behaving and who's accessing it. These services support centralized logging, monitoring, and alerting, all critical for effective security operations and compliance audits. And finally, applications built with SAM can inherit AWS's extensive portfolio of compliance certifications, including SOC 2, ISO 27001, HIPAA, and GDPR. When it comes to defining infrastructure as code on AWS, both CloudFormation and SAM are powerful tools, but they serve slightly different purposes. AWS CloudFormation is the foundational service. It allows you to define and provision virtually any AWS resource using a declarative YAML or JSON template. It's highly flexible and covers the full spectrum of AWS services, from EC2 and VPCs to S3 buckets and IAM policies. However, this flexibility comes with verbosity. You often have to write dozens of lines just to configure something as simple as a Lambda function. That's where AWS SAM, or the Serverless Application Model, comes in. SAM is built on top of CloudFormation and introduces a simplified syntax specifically optimized for serverless applications. It lets you define resources like Lambda functions, API gateway endpoints, and DynamoDB tables using compact high-level abstractions. For instance, with just a few lines, you can configure a Lambda function, its IAM role, API trigger, and environment variables, something that would take significantly more code in native CloudFormation. SAM also includes a dedicated CLI, the SAM CLI, which provides a rich developer experience with commands for building, testing, deploying, and even emulating serverless apps locally. In contrast, CloudFormation relies on the AWS CLI or third-party tools for deployments and lacks any native support for local testing. So while CloudFormation gives you broader coverage and fine-grained control, SAM gives you speed and developer-friendly tooling, especially when working with serverless workloads. While AWS SAM is a powerful tool for building and deploying serverless applications, it's important to understand its limitations so you can use it effectively and know when to consider alternatives. First and foremost, SAM is designed specifically for serverless workloads. That means it works best when you're dealing with AWS Lambda, API Gateway, DynamoDB, and similar services. But if your application includes traditional infrastructure like EC2 instances, EKS clusters, or RDS databases, you might need to fall back to full CloudFormation. Even within the serverless domain, not all AWS services are fully abstracted in SAM. While it simplifies core resources like Lambda and API Gateway, you'll often find yourself writing raw CloudFormation syntax for anything beyond the basics. This limits the productivity gains you might expect from SAM's shorthand model. Another limitation is the dependency on the CloudFormation transform. SAM templates require a transform directive that hooks into the SAM transform engine. While this is what enables its magic, it can also create integration friction when you're trying to compose SAM templates with standard CloudFormation stacks. SAM also sticks with YAML as its template language, which, while powerful, has a steeper learning curve and can be verbose, making it feel less flexible or expressive. Additionally, new AWS features often roll out to CloudFormation and CDK first, with SAM support following later. This means you might have to wait or manually implement new capabilities using raw CloudFormation syntax. Lastly, while SAM CLI supports basic CI/CD workflows, advanced pipelines often require external tools like AWS Code Pipeline, GitHub Actions, or Jenkins. SAM CLI wasn't designed for complex, production-grade automation out of the box. So while SAM is a fantastic tool for rapid serverless development, knowing its boundaries will help you make better architectural decisions and avoid unexpected roadblocks. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.